Hello viewers, Assalamu alaikum. Maqbool Islam is once again in front of you. Today I am delivered about the lecture theorems for the class 10th. The first theorem we start. One and only one circle can pass through three non-collinear points. Theorems 9.1. One and only one circle can pass three non-collinear points. Three non-collinear points. First of all, we understand what is collinear points and what is the difference between non-collinear points. First of all, I explain what is collinear points. Collinear points are those type of points which lies on the same line. Just like we can say that here A, B, C and also D. Here A, B, C and D are lies on the same straight line. So this will be called collinear points. Now if we change the collinear points into non-collinear points, so we change, for example, we write in the triangle form. So A, B, C. So these are the non-collinear points. Similarly, if we write in the circle form, for example, here A, B, C and D are all A, B, C and D are the non-collinear point which cannot pass on the same straight line. So that will be called non-collinear points. So, and the theorem is asking from you three non-collinear points, just only one circle. Only one circle we can draw, and given that, given, we write the statement from the above statement. First of all, we draw the circle. So look here, here is, we can write, for example, O is the center. We draw a circle and here three points are required, three non-collinear points. We write here A, B and C. We can also give the name PQR, LMN. This is your choice. Now we here A, B and C are 3 points. We write the given statement and here we take a circle with center O. Here A, B and C are three non-collinear points. Now we want to the given statement to prove that this one, to prove that, to prove here the given above statement we write, it means that A, B, C are the 3 points just passes on only one circle. So we can write the given 3 points, yeah, just one and only one circle can pass three non-collinear points. These are points are A, B, and C. Now we are required, construction is required, so we take here compass is we are drawing perpendicular bisectors of the construction. First of all, we take the compass according to your own choice, open it. So we take here from A center and draw an arc, and similarly we draw an arc from the outside the circle, and here also we can draw, and here, and also we can draw in here, and we connect this one perpendicular bisectors. And similarly, from the B sides, if we draw perpendicular right bisectors are here, and similarly from here, and also from the internally we draw the two arcs, and these arcs we are connect just like from this ones from here. Now these two bisectors, for example, here we give the name, and here X and Y and L, M. These are the two bisector, right bisector, which intersect each other at point the center fixed point O. Now also we draw the chords of the circles. These are the two chords AB and BC. Joint, these are the construction we are required. And OA, OB and OC are the radius of the circle. And here we give the name A, B, C, D and E. Here D is the midpoint of AB and E is the midpoint of BC. These are the construction we write to constructions. Draw, we draw. If you are explained, then we are taking first of all, we take a center A and B. We draw two right bisector internally and externally. These are connects to each other. Yeah, just to be simple, we draw two right bisectors, two perpendicular bisectors, X, Y, X, Y, and L, M. These are the two right bisectors. We draw two perpendicular bisectors XY and LM to bisect the chord AB at point D. Here AB is the chord of the circle, and similarly the chord BC, similarly the chord BC intersect या cuts at point E. joint O to A, B and C. We get two triangles here, OAD and OBD. Similarly, if we compare OBE and OCE, these are the comparison for the proof. You will do here proof. Statements and reasons. Look here, we are required the comparison of these two triangles. Triangle and another triangle OBD. Now, and triangle OAD one-to-one correspondings. That means that the comparison to each other of the triangles triangle OBD. And the reason we can write one-to-one correspondings. And here, look here, from the both triangles we get here OD is congruent to OD, means that OD is common. Similarly, this is OD. This is the right bisector. It means that we can write here 1 and 2, give the name 1 and 2. We can write measurement angle 1 is also congruent measurement angle 2. Each is right angle, means that it's 90 degree, or we can say that here measurement, and if we put measurement, so this will be changed the congruency as inequality. So measurement angle 1 is equal to measurement angle 2. So we can write measurement angle ODA, measurement angle ODA, because the angle must be between of the two figures, and it will be equal to measurement angle ODB. So we can write the same statement, each is in right angles. Similarly, here we can write AD as congruent to BD, corresponding side of congruent triangles, corresponding sides of congruent triangles, or we can say that here D is the midpoint of here D is the midpoint of AB, that is called chord. Now another points we can OS and OB, that is called radius. OA is congruent to OB, congruent side of triangle, or we can say that radii of the same center, radii of the triangle congruent triangles. So it means that we write measurement OA is equal to measurement OB. So from the above discussion, we have already discussed one side, one angles, and another side AD and BD. From the above statements, so we can say that the triangle OAD is congruent to triangle OBD. Side angle by sides postulates. Side angle by side postulates according to the definition of side angle by side postulates. So from this one we can say that measurement OA is equal to measurement OB. This statement is also we write from here. So equation number first. Now the second triangle we are compare to each other OBE similarly and OBE and OCE. OBE and triangle OBE as one-to-one correspondings. Triangle OCE one-to-one correspondings. Here OE, this line OE is the common points. Common is congruent to OE. Common, and here we give the name of this right bisectors also 3 and 4. Now measurement angle 3 is equal to measurement angle 4. Each is right angle and its equal be 90 degree. Or we can say that measurement angle OEB is equal to measurement angle OEC. Each is right angle. We can also write the above angles. Now we are compare the sides BE and C is congruent. The side BE is congruent CE. Corresponding side of corresponding sides of congruent triangles, or we can say that here E is the midpoint of BC, that is equal to chord. Now it means that here we can write OB is congruent to OC. So the sides BE and OE is common and one angle is common. So from the above discussion we can say that triangle OB is congruent to triangle OCE. Side angle by side postulates. So we can write now it means that here the radius OB is congruent to OC. That is, we can write also radii, or we can say the corresponding side of congruent triangle, or we can say that radii of the same circle. Same circle, just one circle we have already drawn. Now, or we can say that measurement OB is equal to measurement OC. Give the name equation number second. So from equation number first and second, we can apply the transitive property because measurement OB, measurement OBS taking common. From according to the transitive property, we can write here from equation number first and second to get measurement OA is equal to measurement OB is equal to measurement OC, transitive property. Transitive property used. So here we can write OA as congruent to OB as congruent to OC. It means that we conclude that here one and only one circle can pass through the three non-collinear points from the fixed point O. It's verified. Thank you very much for watching once again. Inshallah, step by step we will go and try step by step each theorem. Please subscribe my channel and pray for me. Thanks once again.